repair. Oh my God, you're going to see some stuff when you get into industry like you would not believe. I'm going to give you one real quick story just as a great example. I was putting a first officer's window into an A320 in a hangar in Toronto one day, and next to us was an Air Canada 767-200, so an older aircraft. It was the sister ship to the Gimli glider, if you know anything about that. It's a good read. But anyways, and so we were sitting in the hangar, and we were here. A320. Okay. Sorry, ugly looking airplane. There we go. A320, and over here was a 767. And so 767 was sitting here. Oh my God, ugly looking airplanes. But you guys get the idea. Anyways, there's a 767. Air Canada, the bad guys. Canadian Airlines, us, the good guys. And so we were busy working on it. And we noticed there was a bunch of guys in dress shirts and ties and stuff. And they were walking around like they were maintenance guys. We thought, wow, that's kind of weird. But anyways, so, and what they were doing is they were doing a special test on the aircraft. And what they were going to do, and you guys know about gear pins. So these guys in shirts and ties came in and they put gear pins into the gear, and they were doing a bunch of checks on the airplane, and they were actually going to do a test where they tricked the airplane into, with the ground sense relay, they tricked the airplane into thinking it was in the air. They were going to put hydraulics on, and they were going to select gear up. Don't ask me why. It was just a test, and you know, okay, whatever. And so they were getting all prepped and ready to go, and we were busy doing our thing on the other side. And then it was noon, or probably 11 or something, and so it was their lunchtime. So this really nice van comes in. All these guys in shirts and ties get into the van, and they disappeared for lunch. And we thought, whatever, who cares? They're Canada, right? And so suddenly we see a big tractor trailer come in, or tractor truck come in, and it parks in front of Air Canada's 767, and the guy hooks up the tow bar to the nose gear. Okay, there's a nose gear, and he hooks the tow bar up, and then we hear blah, 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 on the radio, because this guy's super loud, right? And so they can have everything out on the tarmac where it's really noisy and they can still hear. So we hear blah, 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 and then all of a sudden, the tractor disconnects. He takes the tow bar, and he puts the tow bar right behind the main gear, which is a pretty common thing to do, and then he drives away. And we thought, that's kind of weird. He came in, he hooked up, did a whole bunch of stuff, and then he unhooked, and then he drove away. And what happened was he got into the hangar, hooked up to the airplane, and he talked to ops, and he said, I'm on tail 764, and I'm ready to bring it down to the terminal. And they said, no, not 764, it's 746, and it's in the hangar next door. Oh, the guy thought, okay, no problem, I'll go get it. So he unhooked the aircraft, put the tow bar behind the nose gear, and when he put the tow bar behind the nose gear, he looked up and he said, oh my God, somebody put a gear pin in the nose. And we never put gear pins in aircraft unless they're going into the hangar for a long period of time. You guys know why, right? Because you never want an aircraft to take off with gear pins in, right? If you ever put gear pins into an airplane, my suggestion, write something in the logbook. Gear pins installed for, weekend check. Because if you put it in the logbook and they take off with the nose gear pins in, it's the pilot's fault, because they're never allowed to take off with an open snag in the book. Someone has to come in and close that snag. Someone has to take the pins out and say, yeah, we took the pins out. So this guy, rampy guy, oh, there's a pin in the nose gear. He pulls the nose gear pin out and throws it in his truck, and he disappears. Okay, so then it's 11:30, 12:30, whatever, and we get into our crappy old truck and we take off for lunch. You guys can probably figure out what's coming, right? So we come back from lunch, and as we're coming towards the hangar, literally every flashing light in Toronto is parked in front of the hangar. So we immediately go, oh my God, was the aircraft unplugged? Was everything okay? Yeah, everything was okay. And so we come around the corner, and of course, what are we looking at? We're looking at a 767 sitting on its nose, because the guys came back after lunch and they didn't even double check. They just went up into the cockpit and thought, oh, everything's good, let's do the test. It must have been a hell of a ride, because when they pulled the handle up, the cockpit would have dropped about, I don't know, 10 feet, 12 feet. And they, oh my God. And where the tow bar was is right above where all the computers are on the 767. And so when it came down, it just destroyed everything in the bottom of the aircraft. All the computers, all of the nose gear area, the whole front end. Oh my God, it was bad news. So it sat like that for about a week. And then what they did was they got a crane in, they lifted it up, and they put it into a trestle. They made a wooden support. And then it sat in that position for almost 3 months. Because Air Canada was sitting here going, airplane, beer cans. Airplane, beer cans. Which way are we going to go? Recycle, reuse. And finally, at the end of the time, they said, okay, we're going to fix it. And so you make a phone call to Boeing and you say, I got a busted up 767. I need somebody to come and fix it. There's a thing called the Boeing team, and they go, great, we're on our way. They get an Antonov. They put all the nose stuff that they need in, all the toolboxes. And I think it was 12 guys. I saw them. They landed. They rolled out all their boxes, rolled out all the skins, all the frames, all the new stuff, and they started work. And they worked 24 hours a day, 6 guys from midnight till noon and 6 guys from noon till midnight. And they worked nonstop for 2 weeks and totally rebuilt the nose of the aircraft. $12.5 million to fix the airplane. And so that is only one of many stories I could tell you about crazy stuff you're going to see for damage on aircraft. And so, making a short story long, sorry. What are we looking for? When we go for a walk on an airplane, it's our job to find stuff, right? And never go out thinking, everything's fine. Let's just, get this airplane out. Always go out with the eye thinking, okay, I'm going to find something and look for it. And it's interesting, when you walk an airplane a whole bunch of times, you will get to the point where something that's weird will catch your eye right away, because you're used to seeing everything exactly the same way. And if something's changed at all, it will grab your eye and you'll notice it. But again, you got to go out with the mindset of looking at the airplane. We were on the tarmac one night waiting for an airplane to go. The chief pilot was flying that aircraft, and he came out. It was right near dusk, and he came out with a flashlight, and he walked the airplane with the flashlight on the ground so he didn't trip on anything. And he walked all the way around the airplane and back in. He never looked at the airplane once. I would have loved to have had that on video. Could have blackmailed him. But anyways, you got to look at the airplane, right? And so things you're going to see is just regular stuff, things, scratches and that kind of stuff, minor stuff. But goal is to find if anything's not the way it should be, right? We're going to find damage. You're going to see all kinds of crazy damage and stuff. And so you're going to start, when we find damage, the thing that we're going to do is we've got to provide that information to operations, whoever owns the airplane, that kind of stuff. And so we're going to start taking pictures, doing measurements, locating that damage on the aircraft so that people know exactly where it is, and giving that information so that people can start to deal with it, right? And so, again, this is great with phones. Back in the old days, it wasn't as easy. We had the old digital cameras and we had to, download and all, but now it's just like that with phones. That's the time to go back to the truck, get the little 6-inch rule. Hopefully it's only a 6-inch rule, and, hold it up next to it, take some pictures, height, width, depth, and get all that information so that people can say, oh, okay, well, yeah, that's this big, and I can see rivets here. There's a frame. They got to start looking at that, and then they'll know what they're dealing with, or maybe you, and then you're going to get into the books. You're going to get into the SRM. You're going to start finding out what the limits are. Is there a potential repair for damage in that area, and then being able to figure out, is it a small little patch repair? Do we have to now, insert new ribs, or is it now a full reskin and stuff? And so it depends. And our job is find it, define it, and then maybe even, design a repair. If it's a small airplane, AC-43, you may be doing the repair. And in fact, 2 weeks from now, you guys are actually, I'm going to give you some damage on the airplane, and you're going to design a repair for me. You're actually going to do the math and figure out, okay, how many rivets do I need? How am I going to lay this out? What's it going to look like? Is there stuff around it? And so we, have an idea as to what's involved if we have damage on the aircraft. Okay? Keep going, Mr. H. Quickly, gotta keep going here. If we have a sheet of skin, like we have in the shop, and you look at it, okay, there you go. I don't know how well you can see. Don't look at the lines that are on there. Can you guys see? You can see how there's a definite pattern that seems to be going up and down, right? That's the grain of the material. Material has grain. And so one of the things that you're going to find is when you look at a sheet of metal and there's writing on it, the writing, 2024, I don't write so good on an angle. 2024 T4, 040, Alcoa. Whenever they write information, it's along the grain. Okay? Why is there grain? Do you guys remember why there's grain? When we make aluminum, it comes in blocks or billets. And what happens is there's no grain. All of the aluminum are in little globs of aluminum in that piece of metal. Okay? Little circular globs. And there's gazillions of them. But what happens is we take that big piece of metal and we start rolling it. We run it through rollers, right? And we roll it this way and that way and backwards. And it goes from being, this thick to this thick. And those little globs get stretched out and turned into fibers, if you want to call them, or grains, okay? And so we end up with this grain structure. Think of it as wires. That's what I always do. Think of it as wires. It's made up of a whole bunch of wires. And there's glue holding the wires side by side. Okay? So now think about this. If this is wires and there's glue holding them together, which way is it stronger? If you pull on it this way, you're pulling on the wires, right? And it's strong. But if you pull on it this way, you're pulling on the glue. And it's not as strong. So the grain of the metal is super important because it has more strength along the grain than it does across the grain. So if you were to do a repair, you want to match the grain of the piece of metal that you're putting on your skin or whatever. You want to match the grain to the grain of the material you're putting it on so that we maintain the strength where the strength is required. Hopefully that makes some degree of strength or some degree of kind of makes sense, right? And if we're making a repair on a wing, we want to use the same material, same thickness, so that we keep everything consistent. If you had a wing, okay, and it flexes, well, if we put a big chunk of heavy material in there to do a repair, the wing would flex weirdly because there'd be this really rigid section in here. We got a big, repair in here, and it wouldn't flex the same. You'd end up with stress points here, more likely to fail the wing. So we want everything to go back to its original ability to flex and do stuff. So we want to maintain the same material, same grain direction, same alloy, same, format. Then we're going to have to figure out how many rivets we need, and we're going to talk about that based on what the size of the damage is. We're going to decide what we want it to look like, maybe, or someone else will tell us. Then we got to go through all the steps of figuring out how we're going to put rivets on that using edge distance and pitch, all the stuff that we just talked about. And then we got to provide the information so that somebody, one, can assemble it. And if you're doing the assembly, you have to provide the information so that if anyone comes to audit or check, how did you do the repair? Why did you do, what was the criteria? You have to be able to prove that. So you need a drawing of whatever the repair is so that you can prove out why you made the repair the way you did. And so you'd have to have all the information there in order to explain why you chose to do the repair that way. And if you got cracks in metal, like what do we always do? We always drill. If it's strictly a crack, we can maybe deal with it by drilling the ends to stop the crack and then doing a repair over top of it. But if we've got damage, and we've got, bent and screwed up metal, we have to cut out enough so that when we cut it, we've got a flat piece of metal so that we can do a repair to get everything flat again and not have bent, beat up metal as part of that repair. Okay? So we've got to cut out the bent and broken stuff. Okay. Oh, you know what? I'm not even going to bother with this. This is just explains, if you really want to go to sleep, go through these next few slides. And basically it says, if you get a bit of damage in the material, how much of the material has been damaged? How much strength have you lost? How do we go through the process of figuring out how many rivets we need in order to, and the material, to bring back the strength? But what you really need to know is, I must have jumped over it. Let's go back. Yes, there it is. So that's our, so if you get damage and we cut out part of that damage, whatever our final cutout size is, that becomes how much material we've lost for strength. And what we do is we go to a chart, and the chart says, based on the thickness of the material and the size of the damage, you're going to need so many rivets per inch of cutout. And so we're going to use a chart to figure out how do we fix this? How do we bring strength back? And we're going to go through that process, I think, right here, right now. Okay, so, okay, let's go back one. It's going to say, no, let's not do that. That's weird. So we dropped out. Let's have a look here. Okay, so Buddy has got damage, 6-inch damage. He's gone to a chart, and the chart says he needs 26 rivets by figuring out how wide the damage is, how thick the material is, and seeing how many inches of damage he's got times the rivets that he needs. It'll make more sense as we go along. And so he's got to put in 26 rivets to bring the strength back. You know what? I'm not even going to go through this right at the moment. We'll come back and talk more about this in a week or so, about how you figure out how much strength you've lost and how many rivets you need to bring it back. How he laid this out. Oh, man. Rose. There's the chart. That's an AC43 chart. And so you can see on the side, it's got thickness of the material. So if I damage piece 040, I go to my 040 chart. Probably a good rivet to use with that would be 1/8. So I'd go to the 1/8 rivet across the top. I go down, across from 040, and it says 7.7 rivets for each inch per inch of damage. If this was 2 inches across, I would need 15.7, yes, 15.4 rivets. Okay, if this was 2 inches, according to the chart, it says for every inch of damage, which is 2 inches, maximum dimension, times 7.7 rivets per inch, because it's 040, and we're using 1/8 rivets. I need 7.7 rivets, so I would need 15.4 rivets. Well, there's no such thing as a 0.4. I would need 16 rivets on that repair, a minimum, to bring the strength back. Okay? And so we'd use this chart, and you guys are going to use this chart in 2 weeks when you're ready to do repair work for me or design a repair for some damage. Oh, yeah, okay. Man, how are we going to do this? Yeah, okay. Do this super quick. If you've got a wing, where's the stress in a wing? Which way does the lines of stress in a wing go? Okay, root to tip. Oh, don't do it right. Root to tip, leading edge to trailing edge. What do you think? What do you guys think? If you had a wing, where's the lines of stress? Where's the load on a wing? There's my wing. Which way do they go? What do you guys think? I need some suggestions here. Root to tip, leading edge, trailing edge. What do you think? Root to tip. Good, good. Anybody else? Oh, thought I saw something. Oh, man, this thing never rolls down when I want it to. Okay, so you guys are saying root to tip. Okay, so that's cool. Let's go. So there's our lines of stress. So you're up on the wing, you drop a wrench, you hack a hole in the top of the wing. Okay? And there's your damage. I drill the ends, there's the damage. So when the lines of stress come here, they all got to go whoop around like this. This guy's got to go around like this. This guy's got to go around like this. This guy's got to go around. Same on the other side. Like this. This is how and that's why when you get damage, you can see where all the stress builds up at the end, and that's why it's more likely to get worse, right? That's why we stop, drill, or do repairs. Okay, so that's some pretty big damage, eh? Okay, Buddy's on the other wing. He drops the same wrench, but he does exactly the same amount of damage, but his goes that way. How much of an issue is that? Because if we stop and think of the lines of stress here, only a couple that have to kind of go around this. The rest of them go by, and it's like, but it's the same damage. So the question is, the damage that's presented to the lines of stress is what we're worried about, because that's the one that's going to start tearing things apart, right? And so it's the same damage, but it's in a different orientation to where the stress comes from. And so this theoretically is way less damage because there's less of it presented to the lines of stress than when it's this way, right? And so theoretically, this wouldn't need much of a repair where the other one would need a big repair, okay? But the question is, I come back to the same question, where is the lines of stress? And for me personally, I agree, a lot of it would be root to tip, but there are a lot of other lines of stress on that aircraft or on that wing. When you start braking, it's this way, you get the loads, you know, friction loads from when you're flying. And so the big thing is I would never say, okay, because it's this way, it's not a big deal, but if it's this way, it is a big deal. I would always say, no matter what the length of the rivet is, or the damage is, whatever the longest dimension is, I would say I'm going to use that as my W dimension or whatever to know the number of rivets, maximum, or the number of rivets I would need to do a repair, because I don't know which way the lines of stress go. And so if I had a little airplane and I had to do a repair, it would be the same repair for this guy as this guy, because I don't know for sure which way the lines of stress go. And that's why when we get damage, we send it to engineering, because they know better as to which way the lines of stress are. And so one repair might be smaller than another based on the way it sits. And so the big question is, or from my point of view, if you're working on a small airplane, whatever your maximum dimension is, whether it's this way, or whatever, the biggest cutout or the biggest damage is what we're going to use to try and figure out how many rivets do we need to bring strength back. Maybe it's too much, but it's better too much than not enough, right? And that's why we send repairs and damage. We use SRM because they've already taken that into account, or we send it to the manufacturer, or we get someone like a DAR, Design Approval Representative, an engineer who can figure that out and give us an approved repair. Wow, hope that makes sense. That's super fast. SRM, yeah, and so scratches are a big deal on aircraft. A lot of people don't think it's not as big a deal. That repair that I showed you on the Hawker was just a scratch and a tiny dent, and it was a massive repair. So 10% out of 040 is 4,000ths of an inch. That's almost nothing, and that may become a big issue. Pressurized aircraft, that is a big issue. Unpressurized, it might not be as big an issue. So you got to find out what the limits are and what the requirements are, and then kind of go from there. Okay, and so here's an example. I'm going to run you guys through this really quick. Okay, so somebody ran into the airplane. They got 6 inches of damage. It's 040 material. They go to the chart, just like we just did. 040, and they're going to use 1/8 rivets because it makes sense. 3T, right? Just like we talked about up over here. That's what they're using. They're going to use their -4 rivet. It says for every inch of damage, 7.7 rivets required. He's got 5.9 inches of damage on the aircraft, so he needs 45.43. He needs 46 rivets on his repair. So what does he do? He cleans up the repair, makes sure that the damaged area is exactly what it should be, and he starts putting rivets down. I kind of like this design. What did he use for pitch? 7D. If 6 to 8D is a good range, he put it right in the middle. Good choice. 7/8 of an inch. He puts rivets down the sides. So his first row, he puts 1, 2, 3, 4, 5, 6, 7 rivets on one side, 7 rivets on the other side. That's 14 rivets. He needs, what, 46? He needs way more rivets. Then what he does is he puts another row beside those rivets at 3/4 of normal pitch. So he's using transverse pitch for the next row of rivets. You can see that. So instead of being 7/8, he uses 0.656 for a second row. I'm going to blast through that because, again, see, there it is. So he's got the transverse row. He's pulled him in a little closer, 3/4 of what normal pitch was. He's put a second row in, so he's got 6 more on this side and 6 more. That's 12 more rivets. 12 and 14 is 26 rivets. Then he does another set of row behind that, 5 rivets. Another set of row behind that, 4 rivets. Another set of row behind that, 3 rivets. He's got 50 rivets, which is a couple more than he needs. And that's what his final repair looks like. And so that's how he gets the right number of rivets on the repair to bring back the strength. Okay? So there's a lot there. And then the cool part is with transverse, is he's got these sets of rivets that kind of taper away. He puts edge distance out from those rivets. That's the edge of his repair on the ends, across the bottom. Puts a couple of rivets at the top and the bottom, edge distance there. And he ends up with that shape meeting all the requirements. He's got pitch, he's got transverse pitch, he's got edge distance. That's a pretty nice looking repair. The only problem with this repair, my only complaint, is if the stress is going from one side to the other, it's good. But if the stress is going on an angle, well, that's probably not bad. But if the stress for whatever reason is going straight up and down, well, it's not bad. So you must know the direction of the stress. So this must be made by an engineer. Okay. There we go. Approved data, manufacturer's drawing, SRM, AC43. Those are approved data sources for doing repairs. Here's a patch for, again, a damage. The big thing I want to talk about here, because it's going to be something we're going to use, is let's say it's a circular repair. If it's a high-speed airplane, the repair goes on the inside of the airplane. You don't want a big chunk of metal hanging out on the outside. So we put the repair on the inside. We call that repair a doubler, and it goes on the inside, which means you can't see it, right? This would have to be a hidden line, okay? And then what we do is in the center here, we put in a piece of metal, we cut out the damage, and we put a filler in here. The filler is just that, it's a filler. It doesn't count. So if you put rivets into that filler, they're not doing anything. They're just holding that piece of metal there. So they're not part of the repair. The only rivets that count in the repair would be the rivets that are put on the doubler. Okay? And so these rivets are the ones that count. Anything you put on the inside here doesn't count because all it's doing is holding that thing flush. It's not helping to transfer load or energy across the repair. Okay? And so you can see Buddy had to, how many rivets did he need? He's using -4s. It's a piece of 040. He needs 7.9 rivets per inch. He needed 26 rivets. And so he's gone through the idea of figuring out how to lay all those rivets out. So he gets 26 around the outside, and who cares on the inside? And that would be his repair. It says right there, filler doesn't count. Anytime there's damage on the outside, almost always there's damage on the inside. That 737 at the beginning, skin damage on the outside, but all kinds of frames and stuff torn up on the inside, they all have to be fixed as well. And so they would go through the same sort of idea of having so many rivets, pieces, patches in essence, to go over top to bring them all back to strength so they support the outer skin. Hat section. You guys are supposed to know what a hat section looks like. You'll see this shape all over the aircraft. This is a hat section, and we use these as stiffeners all over the airplane. You'll see these lots of places. It was a flat piece of metal. We bend it into the shape and then rivet it down these flanges, and it makes for a very strong, stiff, like longeron or stringer or that kind of thing. And so a hat section is a good support piece, and often we lay them over top of damaged areas to bring strength into the substructure. Okay, hat section. So memorize that shape. help you later on. And when things get really bad, we have to start replacing serious sections of the airplane. Like that whole nose on the 767 had to be redone. My buddy and I were sitting at the gate one day. We were waiting for, you guys probably don't remember, an airline called Zoom Airlines. And Zoom was this big blue 767. And so my buddy Dave and I are sitting at the gate waiting for this airplane to arrive. And it pulls in, and as it turns and pulls up to the gate, there's a hole that size in the side of the aircraft. It was like 4.5 feet, almost 5 feet long, torn open side of the airplane. The airplane had just flown from London Gatwick, 9.5 hours, with that hole in the side of the airplane. And there were people sitting in business class. And so they asked them, "Sir, how was your flight?" "No, it's great." "Were you cold?" "No." "Was it noisy or any wind noise?" "No." They didn't even know. Big 4.5 foot hole in the side of the airplane, and it flew all the way here. The outflow valve that controls pressurization was probably fully closed because all the air was probably coming out of here. But it flew all the way in. And so they ended up doing a repair, and they ended up cutting this out, and the repair looked like this. This was a filler, and then all the repair was done around the outside. And whoever did it, it was the gate in London Gatwick. They did a perfect job because there was a stringer that was here, a rib or a frame that was there, a stringer that was here, and a frame that was here. And so they managed to punch it right in the middle, which was pretty cool because they only damaged the skin. But Boeing told this airline, if you get any more damage on that skin, it's got to be replaced. That repair, we were supposed to be a 3-hour turnaround. It turned into a 2-week turnaround because it had to be repaired. Cost them, it was over $1 million, $1.5 million, something like that. And to reskin would have been in the, I don't know, high singles to maybe 10, 11, $12 million to have it done. And so repairs become big issues. So one of the keys is we're one of the people that works around the aircraft a lot. We're one of the people who potentially could be making damage like that. Be careful. It's super expensive. Okay. We'll spend more time in a couple of weeks talking about repairs and stuff. The layout you're going to need for tomorrow's P2, if you start on the P2, you're going to need it. So have a look at it. Holy, 13 minutes of overtime. Okay, so let's get back together around 1. That gives you an hour and 45 to have some lunch, kick back, relax, have a whole bunch of coffee or Coke or something to get you jazzed back up. And we're going to do more math after lunch. We're going to learn how to bend mount. Okay? Go for lunch. Say goodbye, and then we'll see you guys in a little bit.